All right, everybody. So now we're going over number two, which was from the 2011 test, question number two. So you can see here we're dealing with a two-way table. Part A says, given that randomly selected voter is male, what's the probability that he's registered for party Y? So we're given that restriction, given that they're male. So we're only looking at the males. So we're only looking at this row right here, and then our total is going to be the 200 that we get from that row. So 200 is going to be your denominator, and then what's the probability that's registered for party Y? We have 48 people registered for party Y, so you can do 48 divided by 200. And if you see my work down here, since there wasn't really enough space, do 48 divided by 200, which gives you 0.24. That's part A. Now, part B, it says among the registered voters of Franklin Township are the events is male and is registered for party Y, independent. So we've talked about this a little bit, and we're going to talk about it a lot next week with some new lessons that we do. But when you're dealing with independence, essentially what that means is that two events aren't going to affect the probability of the other. So in this case, what that means is that being male is not going to affect your probability of being in party Y, as opposed to all the people together in general. So if you did that calculation, you would have found that it's not independent. So we say that no, it's not independent because the probability of selecting a random voter from party Y, so this is any random voter, all 500 people together, male and females. So we have 168 divided by 500 equals 0.336. So that probability is not the same as selecting a random male and then being in party Y, which comes out to 0.24. So since the males are lower than just the general population, we said that the male has an effect, being male has an effect on what party they're affiliated with, which means that they're not independent of each other. Independent means that they're not affecting each other. And if they're different, that means that the second event is going to be influencing the other. Again, we're going to be spending a lot of time going over this next week, a little bit more in depth. All right, and then the last one, it says Lawrence Township, so this second township, has the same proportions as Franklin, but they are independent. So that means that the genders, the same proportion of men and women are in each party. It doesn't matter what gender they are. So it says make a segmented bar graph. So to find those probabilities, you're just going to do the total party amounts each divided by 500 right there. You can see the probabilities. When you do that calculation, come out to this. And then you just graph those on your segmented bar graph. So you can see the most people support party X. So that's going to be the largest chunk right in the middle. It's about 50%. You can see that our graph, segment on the graph, goes about 0.5. If you have decimal like this, you can just estimate it if you're segmenting your bar graph. It doesn't have to be exact. It's pretty close. And if you do the calculations on the side right here, then that's going to help support your claim, even if you're not exactly 100% accurate. So I recommend showing your work there as well.